Today we're going to make a quick short video about conversion between different numerical systems, particularly conversion between binary and decimal systems. Now on a daily basis we use the decimal system, which have different numbers from 0 to 9. And we can combine these all together to create different forms. But the decimal system is not the only one we have while doing mathematics. One other system that we have is binary, which is commonly used in computer technology. This system doesn't use these 10 different numbers. It only uses a 0 and 1, which is why it's quite common in computer technology, because you can use the system to represent a two-base system, like true or false and any other two-base system. Now, how do we use this binary system? It's quite simple, actually. The only thing we do in binary system, and let me teach you this by giving an example. Let's say 01001. Let's say that this is a binary number. How to read this in decimal? Well, it's quite easy. Starting from right and going to left, every of these single digits represents a certain value. And we take that value depending on whether the digit is a 1 or a 0. Since this is a two-base system, we are taking the values in a two-base. Does that make sense? So every value from starting right to left is written like this: 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4, and it goes on like this forever. And the resulting decimal value of this is given by adding these values together. Of course, we need to decide on which values to add, and like I said, we figure that out by looking at whether if the digit is a 1 or a 0. If it's a 1, we take that value. If it's a 0, we do not. So the decimal value of this is actually 2 to the power of 0 plus 2 to the power of 3, which is 1 plus 8, which is 9. So the entire equation of this goes like x is either 1 or 0 times 2 and n, the number of the digit. This gives us the decimal value, and the multiplication of these values gives us the whole decimal value. It's relatively simple. What is a little tough to do is converting from decimal to binary. So whenever you're converting a decimal value to a binary, you can think of it as like this. You can start from the biggest binary single digit value that you can think of. For example, for the value 10, let's take 2 to the power of 3, because that's 8. And just try to fill out the remaining numerical spaces. So we have 2 as left. If we take 10 minus 8, that leaves us with 2. And we can fill that space with 2 to the power of 1. That gives us 10. And you can do this by every decimal value, starting from the biggest binary value that you can think of and just lowering them. Now, another way of doing this without thinking about it and just calculating it is that you can do an operation like this. So let's say we have the value of 42. What you're going to do is that you're going to keep dividing this value and the resultant value by 2 until you see a 1. Let's divide this by 2. So we are going to have 21, and this will be 0. Again, divided by 2. We're going to have 1 and a 10 and the resulting value. Again, divide by 2. It's a 0. Again, divide by 2. It's a 1. And again, divide by 2. It's a 0. And the resulting value is of 1. So what you're going to do is that you're going to start by placing these values from the right-hand side, starting with the final resulting value of 1, and just placing all the other values that are left. Let's see. So 1, 0, 1, 0, 1, 0. It's no coincidence that I picked the number 42 for this because it's a quite fun one. And this is your resulting binary. And the key factor in here is that you must remember that if there is a leading zeros before the actual numerical value, that doesn't change anything. I can place as many zeros in here as I want, and that wouldn't change our numerical value. This is still 42 in the decimal place. However, in the actual exam, if you end up with a 6-digit result like this, you might see that in the options there are no 6-digit results. There is a high possibility that there might be a 8-digit results. And in that case, you can look at the starting values of the binary results. And if there are leading zeros, then that doesn't change your numerical value. Just focus on the actual value of your whole binary number. So that's the end of this video. Hopefully you're going to do your best at the exam.